I've made a lot of mistakes over the years, and few have cost me as much as those involving my dust collection system. Often those mistakes could be traced back to my desire to save a little money, but some were due to ignorance and inexperience. In this video, I'll tell you some of the most common dust collection mistakes woodworkers make, many of which I had to learn the hard way. I'll be throwing a lot of facts at you to keep this video moving along, but at the end, I'll give you some references if you wish to really dig into the science behind workshop dust collection. Like many of you, I started out with a shop vacuum. It worked pretty well on certain tools, such as when I connected it to that little port on the fence of my router table or to my random orbit sander, but it was useless on larger tools, such as my table saw. That's because a shop vac moves a limited amount of air at high pressure. When you can get the end of the hose right next to the chips, it does a decent job of collecting them. But as you back it away, you lose the ability to collect the chips effectively. That's why a shop vac works really well on a router table fence. It can suck the chips right off the bit. But the dust ports on most other larger machines are far away from the source of the dust. So while there's a place for shop vacuums in a workshop, such as for handheld power tools, they have limited value for dust collection on most larger machines. Like many of you, I eventually transitioned from a shop vacuum to a single-stage dust collector, and I thought I had it made. Impeller-driven dust collectors, such as this one, work differently than shop vacs. While shop vacs move a little air at high pressure, a dust collector moves a lot of air at low pressure. How much air? This Harbor Freight collector boasts the ability to move 1,500 cubic feet per minute. And that, like the airflow claims on all these single-stage collectors, is total nonsense. They measure the system's airflow with no filters attached, no collection bag, no ductwork, no hoses, no blast gates, not even machines connected. So how much air will it really move in an actual, real-life woodworking setting? If you don't make any of the other mistakes we'll discuss as this video goes on, your single-stage dust collector might move enough to collect the chips that you would normally sweep up with a broom. Not the fine dust in the air. It won't do a great deal to keep your lungs clean, but it may help keep your shop clean. And if you understand and accept those limitations, and you don't do things to further restrict it, a small shop woodworker can get by just fine with a single-stage dust collector. On the other hand, if you wish for more than just keeping the floors cleaner, you may consider a cyclone-style dust collector. This doesn't mean attaching a cyclone-shaped object to your single-stage collector or shop vac. Adding a cone to an underpowered system will not make it more powerful. These aftermarket cyclone attachments are designed to help with dust separation after it's been collected. They will not make a single-stage system or shop vac pick up more sawdust. So don't confuse a cyclone add-on with a well-designed cyclone system that features a large impeller and a powerful motor. These move far more air than any single-stage system on the market. That allows me to attach more complex ductwork and more machines. This is a dust collection system that can be run throughout a shop. This is a chip collector that can service one or two machines. The biggest mistake I made early on was thinking I could connect a bunch of ductwork to my underpowered system. It began with my shop vac. I bought a kit that included some 2.5-inch piping and fittings and even blast gates, and I ran a main duct along the wall that branched out to various tools, just like a real big shop ducting system, or so I thought. I quickly learned that every foot of duct, every inch of hose, every T and Y and elbow and blast gate increased the resistance to the precious little airflow that my vacuum produced. In the end, I got a lot of clogs and I ended up ripping it all out. I'm not saying you can't make a simple shop vac ducting system with a couple blast gates, but shop vacuums work best when you attach them directly to the tool with no more than a few feet of hose. Now what about single-stage dust collectors? Can you attach ducts to them? Yes, but the same principle applies. The more ducts, hoses, and fittings between your tool and the dust collector, the more airflow you lose and the less chips you'll collect. So keep it short and simple. Because it's all about airflow, you want ducts with the smoothest inner walls possible. PVC features the lowest friction surface of any ducting material, even metal. On the other hand, metal ductwork often features smoother transitions between the pipe and the fittings. This is a big factor as well. If you have a complex system with a lot of fittings, high-quality steel ductwork that's specifically designed for dust collection is your best option. It's also easier to disassemble and modify than PVC. Notice I said steel ducting should be designed for dust collection. I once built a complex system with HVAC pipe from a hardware store because it was a lot cheaper than 6-inch PVC. It was a disaster. For one thing, HVAC pipe is designed for air that flows away from the blower, not air that's pulled towards the blower. So all the seams are backwards. This creates ridges that can catch the chips and slow the airflow. And those seams are not well sealed. The system leaked like a sieve unless it was covered in tape. In the end, I tore it all out and I lost a lot of money. If you can't afford high-quality steel dust collection ductwork, PVC is a far less expensive option. It's readily available in 4-inch diameters, and it can be found in 6-inch with some searching. You must size your ductwork to the dust collector you own. If the ductwork is too small, it will restrict the airflow and therefore your suction. If it's too large, it will create too much resistance, which will reduce the airspeed and chips will pile up in the ducts. Without going through the math, I can tell you that a single-stage dust collector is best connected to 4-inch ductwork. A powerful cyclone can handle 6-inch or larger ductwork. But the size of the duct isn't the only factor. The port on the back of the machine is the bottleneck. At the pressure that dust collectors generate, air does not compress. So you cannot reduce a 4-inch duct down to a 2.5-inch port on your small machines. You can do it with a shop vac, but not with a dust collector. You will starve the system for air, which will produce minimal suction, and it may even overheat your dust collector. On my router table fence, I do have a 2.5-inch port, but I also have a 4-inch port open on the underside. Together, these allow enough air to flow through the system to prevent it from overheating, but the suction through that smaller hose on the fence is still not as good as it would be with a shop vacuum, which operates at higher pressure. And forget about reducing a 4-inch hose down to that little port on your random orbit sander or other small power tool. It's just not going to work. Use a shop vacuum for that. If you do choose to run ductwork in your shop, choose your fittings wisely. I've made this mistake several times. I've used too many fittings, making the system too complex with too many bends. Air running through your ducts is like a car traveling through a tunnel. It can move fast on the straight run, but it has to slow down for the curve. And the tighter the curve is, the more it has to slow down. A 90-degree turn is a momentum killer. A T-fitting, then, is a bad choice. If you must split a main into 2 branches, use a Y. Likewise, a tight 90-degree elbow is a poor choice. Instead, use 2 45-degree elbows with a foot or so of pipe in between them to create a more sweeping curve. But keep in mind that even a sweeping curve will slow the airflow a little, and several curves in a duct line can add up, not to mention the bumps and the connections of each of those PVC fittings, and any flex hose in the line. All of this adds up, so keep it simple. Some powerful systems can be connected to multiple machines simultaneously. Others, including all single-stage units, must be connected to one machine at a time. If you don't stretch a hose from the dust collector to your tool, you'll probably use ducts and blast gates to control the airflow. While blast gates are essential, they do create some issues you have to keep an eye on. For example, some must be installed so the air will flow through them in a certain direction. They'll leak if you install them backwards. You can usually identify these by the little screw that puts pressure on one side of the sliding portion of the gate. Many blast gates also accumulate dust in the slot behind the sliding portion. Over time, this gets packed in until the slide will no longer close fully and it'll leak. You may install it so the slide opens downward and the dust in that slot can just fall out. But this orientation isn't practical in many cases, and on some blast gates, the slide will fall open on its own if it's in this position. While I don't understand all the science involved, experts smarter than I am tell me that the more pipe between the collector and the blast gate, the more resistance in the system. So they recommend keeping your blast gates near the main duct line rather than placing them directly at each machine, even though this could be less convenient. It was also recommended to me to use blast gates to shut off entire sections of my large ducting system when it's not in use, essentially making a very complex system behave like a much simpler one. I believe this has to do with preventing the whole system from being pressurized every time the blower's turned on. But there's another reason to close off sections of a complex system when not in use. It eliminates leakage. Every fitting, every hose connection, every blast gate is a potential for a leak. You may not even know you have leaks, but they can all add up. When I close off portions of my system, I also eliminate all potential leaks in that section I'm closing off. I'm reducing what might be a dozen connections down to just one at the blast gate. Another mistake I made early on is one I also see a lot of YouTubers make. They use way too much flex hose. Hose with ribs produce a tremendous amount of resistance to the air moving through it, up to 9 times the resistance as smooth pipe. Think of these as hundreds of speed bumps. The air in the chips will slow down as it passes through, and slow airflow cannot carry chips far. You should use as little flex hose as you can. If you have a ducted system, run the PVC as close to the machine as possible, and then finish with a flex hose if you must. If you run a hose directly from your dust collector to the machine, limit your hose to just a few feet if you can. If you're using 20 feet of hose, try moving your collector closer to the tool so you can shorten that hose. You might be surprised at the difference. Flex hose connections are also notoriously leaky. I recommend clamps that are designed for that purpose with bridges that produce more even clamping pressure over the ribs. It's common to attach what is called a dust sweep to ductwork, which acts as a dust pan that sucks up everything you broom into it. I've also used a vacuum wand which connects to my ductwork via a flex hose to clean up piles of chips or even vacuum the entire floor. But you should be aware that fires have been started this way. In some documented cases, screws or other pieces of metal were sucked up and a spark was created when that piece of metal struck the steel impeller in your dust collector's blower. That spark then smoldered in the dust bag for hours or even days until a fire was ignited. Shops had burnt down from this. One way to mitigate the risk is to attach rare earth magnets to the dust sweep opening and hope any metal sticks to the magnets, but I'm not sure that's completely effective. A trash can separator or a cyclone system will also separate the chips and metal out of the airstream before it reaches the impeller. We'll talk about these shortly. One of the least understood parts of woodworking dust collection are the filters. Most folks think of their dust collector's filter as they do the filter on their furnace. If you put a really fine filter on, it's great because you're going to get lots of fine dust out of the air. And that is kind of true. Older single-stage dust collectors came with terrible filter bags. They let all sort of dust out. Then they started making 5-micron filter bags, which is better, but still not even close to good enough. Incidentally, filter bags cannot be washed. Not only will that remove the coating that turns that fabric into a fine filter, but filter bags also rely upon a buildup of dust in the fabric to close up the pores and provide better filtration. You don't want to remove all that dust. The real problem with filter bags is they suck up the dust from your tools, which are about waist high, and they pump it out through the shop at nose level. You may end up breathing more of it than you would have standing right in front of the table saw. That's why some people call them not just dust collectors, but dust pumps. So why don't they make filter bags with finer filtration? Because the finer the filtration, the less airflow through the system, and therefore the less suction. For air to come into the collector, it must escape out through the filter. The smaller the holes or pores in that filter, the less air can escape, and so the less air can come in. The solution would be to add a lot more tiny pores, but there's only so much room on filter bags. If you were to make the holes small enough to keep out all the dangerous fine dust, you would have to cover the filter with many, many, many times more fine pores. You need a lot more square footage of filter material to let enough air escape through those tiny holes. So the solution is a canister filter. These are full of pleated filter media, all folded up inside. It provides many times the square footage as the bag, and it can also filter out much, much finer dust. A canister filter will not only keep your air cleaner, it will also improve your suction because it won't restrict the airflow as a filter bag does. Remember, they rate dust collector airflow with the filters off. When they put that bag filter on, your airflow is cut down dramatically. A canister filter will go a long way to restoring the capabilities of the machine. I've tried trash can style separators over the years, including the plastic lid types and the baffle style. They have some advantages, particularly in the way they keep all but the finest dust from reaching your filters. That extends the time between your filter cleanings and the overall lifespan of the filters. But the trade-off is they reduce your airflow. Some reduce it by more than 50%. If you already have an underpowered single-stage dust collector, you can't afford to lose more airflow, especially if you plan on hooking up some ductwork. I'm not saying I'm against separators. There are many cyclone attachments on the market that I haven't tried. Some folks like them. But keep in mind that everything you attach to your dust collector will reduce its airflow to some extent. If you're going to attach a separator, you might have to make compromises elsewhere, such as simplifying your ductwork or shortening your hoses. And as I said previously, adding a cone to an underpowered dust collector will not make it more powerful. A cyclone cone affects chip separation after it has already been sucked up. It won't make a single-stage system pick up more sawdust because that small impeller and underpowered motor is only capable of moving the air it's already moving. That said, if a separator will keep your filters cleaner, well, there's some benefit in that because that can keep your system working at peak efficiency longer. As with everything, there's always a trade-off. If you want to try a separator, be sure you can take it back if it doesn't work well in the system you have. I've thrown a lot at you, so let's quickly sum it up. Shop vacuums are good for tools with small ports. Dust collectors are good for tools with 3-inch or larger ports. Single-stage units are good for collecting the chips you would normally sweep up with a broom. Large cyclones will provide much better overall dust collection. If you plan to connect your dust collector directly to one machine, don't use 50-foot of flex hose. If you plan to attach it to multiple machines, keep your ductwork simple. Use as few fittings as possible, avoid tight bends, and limit your use of flex hose. Size your ductwork to your system. That means 4 inches on most single-stage collectors. And don't starve your system for air by reducing that 4-inch line to smaller than 3 inches. Remember, leaks can add up, so keep your connections sealed and your blast gates clean. And it's all about airflow, so consider upgrading to a canister filter. You'll be surprised how much it helps. On the other hand, beware of things that reduce airflow, such as trash can separators. If you wish to learn more about the science behind everything I said in this video, and a lot more about dust collection, check out billpence.com. It's an amazing, comprehensive resource on the subject. See you next time. We couldn't do what we do without folks like the Bushy family over at Clearview Cyclones. Not only do they make the best dust collection cyclones on the market, but they're woodworkers supporting woodworkers. They're the sponsor of this video, and I really hope you'll thank them by visiting their website and using our discount code below this video. Wait, don't go yet. If you're new here, please subscribe and remember to ring the bell. I would really appreciate that. Give us a thumbs up, or better yet, leave us a comment. I always read them. And be sure to check out the latest issue of Stumpy Nubs Woodworking Journal. It's always packed with tips, tricks, and tutorials designed to make you a better woodworker.